Scientists use graphs to represent trends that they are observing in their data. And one thing that we do in Biology 100 and Biology 101 is learn to evaluate data and interpret data. So we do this mostly in our labs, but occasionally we'll do this in class as well. So you may be asked to create a graph of some sort. There's lots of resources online about how to make different types of graphs, why you would make different types of graphs. I found one for you. If you Google NCES graphing tutorial, you'll find some information, and it's actually for kids, but it's really great, simple information about why you would use each type of graph that you might encounter. So a line graph, a Venn diagram, a pie chart, a bar graph, just different types of ways of representing data. You can obviously find this in your textbook as well, and we'll cover different types of graphs as we go through the semester. A bar graph is used to compare data between different groups. Sometimes it's used to also track changes over time, but a bar graph is not usually the best way to represent changes. It's really better to show a comparison between multiple groups. So if you have two or more groups and you want to very quickly visualize the results for whatever data you're collecting between those groups, a bar graph is going to be the way to go. Now, for our class, you do not have to make them super fancy. Really, I'm looking for a few key things. Have you labeled them correctly? Have you put the correct variables on your axes? Have you made it neat and tidy so that I can see what you're doing? And have you given it a really great title? So we are going to use a bar graph, again, to compare multiple groups. If you are trying to compare changes over time, you really probably want to use a line graph, especially if your changes are slow and gradual, because a line graph is going to more clearly show trends, whereas bar graphs can get a little bit messy if you have a lot of groups and you're looking at lots of things changing at once. So really think about what you might be trying to show with your graph, and then you'll evaluate if you want to do a bar graph or a line graph. So here's an example that I pulled from the internet. It's just a really quick bit of data that shows from about 20 individuals or so how they categorize their favorite type of movie. So we have 5 groups here: comedy, action, romance, drama, and sci-fi, and the number of people from their survey that have chosen these different types of movies. And then on the bottom, we have the bar graph. You'll notice that it's nice and colorful. That's just to help separate the data and really give a good idea of the different trends, so we know clearly which groups are which. So it might be nice to also have a key here, but you'll see that the bottom, the x-axis, shows the different categories, and this is going to be the independent variable. And our independent variable is the one we control. So in this case, we have set our categories. We have decided that we are going to ask who likes each of these categories. On the other side, we have the y-axis. And the y-axis is always going to be the dependent variable. And that's going to show our data, what we are collecting. Because when we walk up to these people, we might say, you can pick one of these 5 categories that we have chosen, but we don't know which one they're going to pick. That's what makes that the dependent variable. That's the data we're collecting. You'll notice that there are units provided on this y-axis, and they are spaced evenly. So the way that you space your units really depends on the data that you have and how much you're trying to represent. You want to make it reasonable for the amount of data that you have. So we only have around 20-25 people here. Our highest value is 6, so it wouldn't be reasonable to label this up to 100 or even maybe up to 20, because what we're going to end up doing is squishing our data down at the bottom. So we want to spread out this y-axis as much as we can so that we can more clearly see the trends in our data. Then of course we have a box or a bar for each one of our data points in our table here. So we have comedy, 4 people chose comedy, so we make our bar up to 4. You always want to make sure that your x-axis and your y-axis are labeled appropriately. So if you're using something like time or a volume like milliliters, a temperature like Celsius, you want to always make sure that you provide that information as well. Lastly, we want to provide a title for our graph that represents what the graph is showing. So this title needs to be specific. So you don't want to say something like my data or lab data. You want to explain what someone is seeing in that chart. And the reason is that you want to show the reader very quickly whether or not they need to look at this graph. And if it just says lab data, well, that's not going to tell them anything about what you're showing. You're trying to show what favorite types of movies people choose. That's the data. So you want to describe what data you are presenting. So most of our graphs in this lab will either be, in this class will either be bar graphs or line graphs. Again, you want to use a line graph to show trends, and both bar graphs and line graphs are going to show comparison between multiple groups. So usually your lab manual or your assignment will tell you what type of graph you're supposed to be using. In this case, we're talking about a bar graph. And the example that I'm going to use is from the Biology 100 Lab 1 activity, which is about the dissolving rate of Alka-Seltzer. Now, depending on the semester, depending on the class, you may have done temperature or surface area or both. I'm going to do temperature today. So the effect of temperature on how quickly the Alka-Seltzer dissolves. So we want to start by making a title. So we might say something like the effect of temperature on Alka-Seltzer reaction rate. So the most common mistake that students make with making their graphs is flipping the x and y axis. So you always want to determine which is your independent variable first, the one that you control. So in this lab, we have chosen to control the temperature. That's the one that our hypothesis is testing. So you might have used something like 5 degrees, 22 degrees, and 40 degrees. This may differ depending on semester and depending on class, but you would fill in your own temperatures. Or if you're using the surface area, you would instead put here the treatment that you did. So did you use a whole tablet, a quartered tablet, or a crushed tablet? You always want to make sure you label this with units. So you can either label that here with your data, with your categories, or you can write it on the bottom and say something like temperature. And we always want to label our units in degrees Celsius. On the y-axis, that's our dependent variable. So this is our data that we are collecting. We don't know what the rate is. That's what makes it dependent. It depends on the temperature. So up on the side here, we're going to make some regular increments. You'll have graph paper to do this. And again, you want to choose increments that make sense for your data. So usually these end up less than a minute. So I'm going to go in increments of 5. You might do increments of 2. It just depends on what's appropriate. You might do something different. So I'm going to label it up to 40, and our data is going to be time in seconds. So I've labeled it and I've provided my units. Now for each of our data points, you'll go back to your class average, or if we ran out of time, you might just be graphing yours. Most semesters will have a group bar and a class bar. So that just depends on what we get to. So I'm going to say that our class average for 5 degrees Celsius was 40, and our group data was 35. Now you will probably want to color code it or something, somehow make a key here. I'm not going to do that because switching pens is a little bit of a pain. But then we might have 22 degrees Celsius, and maybe we got for this one that our class data was 25 and our group data was also 25. And then for 40, maybe we got class data that was about 15 and group data that was 14. So class and group. And so this shows us that the colder temperature took longer to dissolve the Alka-Seltzer. Warmer temperatures went more quickly. You may have gotten completely different trends, maybe nothing like this. This is just the graph that I happen to be drawing. So when you analyze your data, you really just want to stick to what you see. You don't put any interpretation in your analysis initially, or at least your statement of what you got. You're just going to simply say, this is the data that I received. Once you get to your conclusion, you'll start to analyze it. Why did you get this? Did you have any problems? Did you support your hypothesis? So if your lab or activity asks you to just describe your data, that's what you're going to do. You're going to leave your opinions out of it. You're going to leave your interpretation out of it, and you're going to save that for your conclusion, where you might talk about whether or not you supported it and why, what is it about your trends that support or don't support your hypothesis and your prediction.